Okay, so here we go on 2.4. So this week you are going to do 2.3, 2.4, and 2.5. You are also going to have a quiz this week. It'll be on the following Wednesday. Okay. So right now we're going to be talking about points, lines, and planes, and the postulates. Remember that we talked about postulates in 2.1 to 2.3. So they're essentially rules that we accept in geometry. I'm going to skip down to here. You guys have already talked about these postulates. Postulate 1 is the ruler postulate. I need for you to know the ruler postulate. I don't necessarily need for you to know that that is postulate number 1. Remember, the ruler postulate just means that if I have 2 points, I can line them up on a ruler, and I can subtract this guy minus this guy to get their distance. Segment addition postulate just means that if I have a segment, that this piece plus this piece will equal the whole segment. Protractor postulate, same thing, is if I have an angle, I can line it up with a protractor and I can find the number of degrees. Angle addition postulate just means that I can take this angle plus this angle to get the whole angle. Okay? Postulate number 5 just states, and these guys, we've actually already talked about these. We're just putting postulate numbers to them. Through any 2 points, there exists exactly one line. So these are all concepts that we talked about in Unit 1. We're just putting postulate numbers to them. So if I have 2 points, there's going to be one line that will go through those 2 points. Then the opposite of that guy, right? If I have a line, then that means that I have exactly, or at least, not exactly, I have at least 2 points. There's an infinite number of points on a line, but we have to have at least 2 points in order to make a line. If 2 lines intersect, then their intersection is exactly 1 point. So I have a line here, line here, line here, line here. Their intersection is exactly 1 point. The only difference between that, there is one exception, is if I have 2 lines that are on top of one another, they're essentially the same line at that point. So that's why they don't talk about that there. Through any 3 non-collinear points, so non-collinear means that they are not in a straight line, they're exactly one plane. So since there's 3 points, I can make a plane there. 8 and 9 are opposites of one another. 9 is saying the opposite. If I have a plane, then I have to have at least 3 non-collinear points. Of course, I could have a ton more, but there has to be at least 3. Postulate 10, if 2 points if 2 points lie in a plane, then the line containing them lies in the plane. Okay, so this should be lies. So if I have 2 points on this plane, that means that there has to be a line that goes through those 2 points. Therefore, that line would be on that plane also. And then 2 planes intersect in a line. That's like my wall back here. This wall hits that wall at a line. Remember, it's not a segment, it's a line because planes actually never stop. They go on forever and ever, and that's why it would be a line. Okay? Use the diagram to write an example of the postulates from above using this. So I want you to pause me, and I want you to try to figure out some answers to these. If you're confused on what you're supposed to do, just listen to me do postulate 5 and then pause me. Okay? So postulate 5, so I'm going to go back up to the top. It says through any 2 points there exists exactly one line. So I see that there's point B and point C, which makes line BC. Okay? So that's what they're wanting here. So go ahead and pause me if you haven't already done so. Postulate 6 is the opposite of that. So I have line BC, therefore, 3 dots in a triangle is a shorthand for therefore. I have point B and point C. Postulate 7 says if 2 lines intersect, then their intersection is exactly 1 point. So I have line T, so that's this line, and I have line AC. Intersect at point A. All right. Postulate 8 states through any 3 non-collinear points, there exists exactly one plane. So we have points B, A, and C that make that shaded plane. So that equals, oh, that plane is called T, not line T. This is line AB. That's my fault, guys. That makes plane T. 9 is the opposite of that. So I have plane T which means I have points A, B, and C. Guys, if I look at plane U, B and C are on U, but A is not on U, and we don't have a third point, so I could not use plane U on that. Postulate 10 says if 2 points lie, that should be lie, not lies, lie in a plane, then the line containing them lies in the plane. So I have points A and C. Therefore, on plane T, therefore line AC is on plane T. Postulate 11, if two planes intersect, their intersection is a line. So plane U and plane T, they intersect at this line BC or CB. Okay, next page. Sketch a diagram to show the given information. Okay, guys, this right there means perpendicular. And from Algebra 1, remember perpendicular are two lines that intersect at a 90-degree angle. So I have AB and BC. That means that their point of intersection would be B because they both contain B. So that point there is B. I'm going to put A somewhere on here. I'm going to put C somewhere on here. It doesn't matter. I could have put A here. I could have put C there. That's fine. But I have to show that they are perpendicular, so I have to put that 90-degree angle symbol in there. Okay? Pause me. Try 9, 10, and 11 on your own. Unpause me when you're done. Okay. 9, 10, and 11. Line M bisects segment ST. I know that's a segment ST because it doesn't have the line. Line M bisects this. So that means that this is congruent to this. So I have to show that it's congruent by putting those little markings. LN, so that's a segment LN, is perpendicular to plane A, and plane A bisects LN. Okay, I'm not going to be the best person to draw this. So here's a plane. Plane A has segment LN, so it hits this plane, and it comes out the bottom. LN, but it bisects, the plane bisects it, so this piece is congruent to that piece. Not too bad. Oh, and it's perpendicular, so I have to show this perpendicular by showing my 90-degree angle of that line hitting the plane. Plane G intersects plane H in line EF. Okay, so we have two planes. This really is going to be a bad picture, I promise. So we have plane G. Then we have plane H. They intersect at line EF. See if I can make this any better by making this dotted. Not really. Okay. Point D lies in plane G. Oh, what's this plane? This is plane H. Point D lies on plane G, and DE and D to E is perpendicular to plane H, so it hits a 90-degree angle. So I put a 90-degree angle there. Whew, that was a lot in one picture. Okay, next section. Can the statement be assumed to be true from the diagram? So remember, we can only assume things to be true if they actually tell us they're true somehow in geometry. So ray AB, so ray AB and ray AD are opposite rays. We can make that true because they have the same endpoint, they go in opposite directions, and it's a straight line. So that would be true. So try 13 through 19 on your own, so pause me, unpause me when you're done. Angle B to A to C, so this angle, and C to A to D are supplementary. Well, they do make a straight line, so that would also be true, because A to D is a straight line. B to A to C is congruent to B to A to E. Well, this is 90 degrees up here, C to E is a straight line, so that would make this 90 because the line has 180. So 180 minus that 90 would make that 90. So they're both 90 degrees, so that would be true also. Line CE, right here, is perpendicular to plane S. It has the 90-degree angle, so that is true. We have a lot of truths here, and that's okay. Line BD lies in plane S and in plane T. That is true because it's the line of intersection of both planes, so it would be in both planes. If G is a point in plane S, then C to G lies on S. So if I put G here, they're saying if I connect those 2 points, would it be on that plane, that shaded plane? No, not necessarily, so that one would be false. CE bisects B to D, and that is true because do you guys see the little markings there? So that one would be true. Plane T bisects B to D. Plane T? No. Plane T goes through the entire B to D. So B to D lies on plane T, so it can't bisect it. So that one would be false also. Okay, one more page for this notes. So a friend emailed you the following statements about a neighborhood. Use the statements to complete A through E. I want for you to for sure pause me, and I want you to make a picture of this. We have to remember it goes north, south, east, west. Okay? So that's my clue to you. So pause me and try this. Unpause me when you're done. Okay. Building B is due south of Building A. Building A and B are on Street 1. So B is due south of A. So that would be south of A. They're on Street 1. Okay. C is due east of Building B. Due east would be this way. B and C are on Street 2, so this is Street 2. D is south, east, so south and east, so somewhere down here. So this would be south, this would be east, so if I combine that, it would be somewhere over here. That's where D is, and it's on Street 3. E is due west of Building C. West would be this way. So it's somewhere over here, right? Building E is due west of Building C. But I also have to know that B to D to E is formed by streets 2 and 3 as acute. So E is actually somewhere on here in between B and C. Because this has to be an acute angle. If I had put it over here, it would make that an obtuse angle. It would be E to B to D, and it would be a big angle. Okay, where do streets 1 and 2 intersect? Here's Street 1, here's Street 2. They intersect at point B. Classify the angles formed by Street 1 and Street 2. Well, that was due north and due east, so that actually made a 90-degree right angle. What street is Building E on? That would be Street 2. You guys can't tell me when you can't see. Sorry. Okay. Is Building E between Buildings B and C? Yes. Because angle B to D to E, or D to B to E, is acute, and that's the only way to make that an acute angle. Okay. So that is your work for this, or your notes for section 2.4. There will be a homework assignment and 1 or 2 homework assignments in Schoology for you to complete, and then you'll have 2.5. All right, thanks, guys.